Simplify the square root of 28x to the fifth times y squared. Again, we're going to split this up into two radicals, where the first radicand is a perfect square, so that we can actually evaluate the square root of the first one. So let's look at 28. We need to factor 28 so that one of the factors is a perfect square. And we can do that by writing 28 as 4 times 7. Now, x to the fifth is not a perfect square, but it does contain some. It actually contains two perfect squares. X to the fifth is divisible by x squared, and also x to the fourth. And since x to the fourth is the biggest perfect square it contains, we're going to pull that out front. It's kind of like when we're pulling out the GCF, we're looking for the biggest factors that each term have in common. Here, we're looking for the biggest perfect square that each of the factors contains. So x to the fifth contains an x to the fourth, and then that leaves us with an x as the leftover. X to the fifth is x to the fourth times x, so we split it up like that. Y squared itself is a perfect square, so we're going to put the y squared out front. And then when we take the square root of 4x to the fourth y squared, that gives us 2, and then x squared, and then y. And then we've got the square root of 7x at the end. And this is our final answer. Again, just a quick reminder, we're going to assume that the variables are all positive here. If x was negative, then we would end up having a negative here, and it would be undefined. So there are always going to be some suppositions that we have, some restrictions on the variables. And in this case, we're just going to assume that the variables are non-negative to make things work out.